Let us consider this problem. The following data gives the results of inspection of 100 items per day for 10 days. Construct a D chart. Okay. See, on the first day out of 100 items taken, some 6 items are found to be defective. And on the second day, in a sample of 100 items, 8 items are found to be defective. The data is given for 10 lots for 10 days. So what is the sample size here? It is not 10. The sample size is 100. Okay. D represents the number of defectives. This is the variable D. And K is the number of lots. How many lots are there? One lot is selected per day. So you have 10 lots. And D bar is summation D by N. You should add D values. 27, 30, 32, 36, 38, 40. Divided by 10 is 4. Okay. Now P is equal to proportion of defectives is D by N. So D is equal to N times P. Expectation of D is N times expectation of P. Expectation of D is D bar and expectation of P is P bar. So if this is the relation, you can find P bar is D bar divided by N. That is 4 divided by 100. That is 0.04. Now let us compute variance of D, that is variance of NP, that is N square into variance of P. But what is variance of P? Here your D is a binomial variate. Okay. In binomial distribution, variance of P, D is a binomial variate. Then if it is in terms of P, it is PQ by N, a Bernoulli variate. Your variance of P is PQ. In the place of P, you have P bar into 1 minus P bar by N. 1 N gets cancelled. So you have NP bar into 1 minus P bar. Your N is 100. P bar is 0.4. 1 minus P bar is 1 minus 0.04, 0.96. Okay. Now let us calculate this. Into 0.04 into 100. So you get 3.84. Now let us find the upper control limit, which is NP bar, right? What is your N? 100 and what is your P bar? 0.04 plus 3 into square root of NP bar into 1 minus P bar, square root of 3.84. And your UCL is 100 into 0.04 minus 3 into square root of 3.84. Okay, let us compute this. It is 9.88 and here minus 1.88. Okay, fine. So let us construct a D chart for this data. The maximum value you have here is, the upper control limit is 10. So let me select this scale. And the sample number, that is the lot number, is taken on x-axis. You have 10 days, right? Fine. Now the lower control limit is a negative quantity. You know that the number of defectives the minimum value can be 0. So LCL is taken as 0. You cannot have a negative value here. And you try to have this understanding. When whole numbers are taken, you should round the values to 1 decimal place, right? Because the difference is 1, which is divided into 10 parts. So each small line is counted as 0.1. So you can plot 9 point something up to 1 decimal place. So round it to 1 decimal place. 9.9 is the line just below 10. Okay. So you draw a line. This should be a dotted line, splitted line, because the upper control limit, you know, we represent it by splitted lines. Okay. The upper control limit is 9.9. And what about the control limit? It is NP bar, 100 into 0.04, which is 4. Okay. So draw your control limit as a thick line. Control limit is 4. Okay. Now let us plot the values. This is D chart, right? In a D chart, D values are plotted on y-axis. For the first, let me show the data. For the first lot, the D value is, see, 6. For the first lot, D value is 6. For the second lot, it is 8. For the second one, it is 8. For the third one, it is 5. For the fourth one, it is 4. For the fifth one, it is 4. For the sixth one, it is 3. For the seventh one, it is 2. For the eighth one, it is 4. Right? For the ninth one, it is 2. For the 10th one, it is 2. Fine. You may think that just by inspection, if the D values are between the upper control limit and lower control limit, we can simply say that the process is in control. What is the need of constructing the chart, control chart? You may think that, but this control chart speaks about more facts. See, if there is an increasing trend in this control chart, you can understand that some difficulty, some problem has started in the process, right? Here all points are between the control limits, so the process is in control. No upward trend is there, right? No upward trend is there. See the points? These points are near the control limit. So more deviation is also not observed. Initially there was deviation, fluctuation, but after that the process seems to get stabilized. Okay. So while writing the conclusion, you write, since all the points fall within the control limits, the process is in control. Which is in control? The number of defectives is in control. Fine. Thank you.